Hi, this is Mr. Bo with Mr. Bo English, and we're in the middle of doing our Algebra 1 with quadratics. Uh, and last time we did our zero product property video practice walkthrough, and this time we're going to do the one on graphic quadratics um, in factored form. So let's go ahead and do this. I've already done this once with my regular internet students. So. Okay, so what we need to remember for graphing is our parabolas. We've got a couple of things here. Our parabolas are going to either open up or open down, and generally we can look at the coefficient, the leading coefficient. If the leading coefficient looks like negative x squared, negative something x squared, then it's going to open down, and if it looks like something x squared, then it's going to open up. Okay, and to graph, we really need to identify a couple of things. We need to look at the x-intercepts, which we talked about last time. You'll remember when we studied about lines, linear equations. We worried a lot about the y-intercept, and that's also true here. So the y-intercept is on y and the x-intercept is on x, but otherwise it's the same kind of thing. We're going to learn about how to, excuse me, my pen's not working. We're going to learn about how to find the x-intercepts really easily, and then the bottom here, lowest point or the highest point, those are called the vertex. The vertex is down here. And there's a vertical line that goes through the vertex that is called axis of symmetry. And symmetry just means it's the same on some sides. So it's going to be the same on this side and the same on this side. And so the distance on these two is going to be the same if it goes. Wow, that was not good. Got a new pen here. If the parabola opens down, then these two distances are going to be the same too, and they're kind of like a mirror of each other. And we saw that when we were working with absolute values too. That when you're working with negative domain for that, then it's kind of like a mirror too. So let's look at our first problem here. Our first problem is y is equal to x minus 5 times x plus 1. And the first thing we want to find, it asks us for, let's see, the vertex. It wants us to find the vertex. So we're going to find the vertex down here. In order to find the vertex, we need to figure out where that line of symmetry, that axis of symmetry is, and then find the y for that. So we got two steps for find the vertex. And our first step, number one, is find axis of symmetry, and then the number two is use that x value to find y, and then we'll have our xy coordinate of the vertex. So first thing, if we want to find the axis of symmetry, we need to find the x-intercepts. So x-intercept is where y equals 0. So we'll set this. Okay, that means on the zero property, zero product property that we studied last time, one of these two is 0, or maybe both. So either x minus 5 is equal to 0, or x plus 1 equals 0, or maybe both, but in this case it can't be both. So that leaves us with x equals 5, or x equals negative 1. So if we have our x-intercepts here, we have those two spots, and then we need to find we need to find the axis of symmetry, and that's going to be right in the middle. That's going to be the same distance from both sides. It's going to be the average. So we're going to take -1 plus 5, add those two together, divide by 2 to find the average, which is 4 divided by 2, which is 2. That means the axis of symmetry happens at 2. So now that we done step 1, we found the axis of symmetry. And so step 2, we're going to use that x to find y. How do we do that? We plug it in. 2 is going to be 2 minus 5 times 2 plus 1. And that is -3 times 3, which is -9. And so let's see, our vertex is down here at 2, -9. And if we want to draw our parabola, we'll just draw it like this and make sure it goes through those points. Okay, there should be a comma here, you can't see it. 2, -9. So it asks us what's the vertex of the parabola. That's what it is. 2, 2 and -9. Alright, I'm going to switch to grid paper here, graph paper here. Alright, so our next question, let's look at the question carefully. What is the vertex of the parabola? It's the same question, but we got two parts, and we're going to graph. So, what are our steps for find the vertex? Okay, step number 1, find the axis of symmetry. And step number 2, we'll use that to find the y, and then that gives us our x, y coordinate for that. Okay, so let's start. Our formula for this is x minus 2 times x minus 6, and since we want the x-intercepts, we're going to need to set that to 0. Alright, the x-intercept is when y equals 0, so we said y equals 0. When y equals 0, that's when it crosses the x-intercept. And by our zero product property rule, we know that x minus 2 equals 0, or x minus 6 equals 0. So that means x is equal to 2, or x is equal to 6. I'm just going to draw that was really ugly. I'm not used to graphics pen. I just bought one yesterday, so I'll probably get better at this. So you either got 2 or 3, 4, 5, 6. There we go. There's our two intercepts. And we want to find the axis of symmetry, which runs right down here, right down the middle. And it's right in the middle between 2 and 6. So 2 plus 6 divided by 2 equals 8 divided by 2 is equal to 4. So my axis of symmetry is at 4. And now I want to find the vertex. Okay, so for the vertex, I want to set x equal to 4 and then find y. So what is y? My question is, what is y when x equals 4? I know the vertex is on this line, x equals 4 line, but I don't know where, so I'm going to set and substitute x equals 4 and then find out what y is. So y is equal to 4 minus 2 times 4 minus 6, and that is equal to 2 times -2. That's interesting. Last time it was -3 and 3. This time it's 2 and -2. I think I see something that maybe we should watch out for, a way for us to check ourselves. So y is equal to -4. That means 1, 2, 3, 4. And then we can kind of sketch our parabola here. Okay? And so what's the vertex? The vertex is 4, comma, -4. and I know one of my x-intercepts is 6, and the other one is 2, and that's a good way for me to check if I'm using this program. It will make it symmetrical automatically, and so bam, this came out right. That's a good sign. It's a good sign for us. Let's take a look at the next one, okay? Remember our steps for oh, we don't have to do that. This is a new one. All right, so always read the directions. Always read the directions. Graph the function. So it wants us to graph. So if I want to graph a function, graph a parabola, I need some things. Okay, I really need 3 points. I need x-intercepts, and I need the vertex. And if I have those 3 points, then I can kind of sketch what the parabola is going to look like. So we need to find the x-intercepts, and then we need to find the vertex. And to find the vertex, we need to do what? We need to find the axis of symmetry, and then 2, we need to find we need to find y at that axis. Okay. So let's get started. Our function doesn't look like y here, and the function looks like h of x. So, but it really is no different. In fact, even our graph says y. It doesn't say h of x here. So obviously Kant thinks it's similar. So we want to find the x-intercept. So we set the function h of x to 0, and then we get x plus 3 times x plus 7. Okay, that means x plus 3 equals 0, or x plus 7 equals 0. And that means either x equals -3 or x equals -7. So I got -3 and -7 here. I want to find the axis of symmetry there in the middle. So I take -3 plus -7 and average them, divide by 2. And that is -10 divided by 2, which is -5. If you can do this in your head, that's great. But I always tell my students, if you're not sure, you're thinking, I can't keep it in my head, write it down. Keeping it in your head is great, but it's easy to make mistakes in our head. So if we're not sure, we start getting even 90% sure, we should write it down. So this is -5, so this is at -5, and now I want to find that y at this point. So h of -5 is -5 plus 3 times -5 plus 7, which is equal to -2 times 2. And there we go again. We got the same numbers. One is negative and one is positive. 2, -2, and 2. They're coming in pairs. That really makes sense, since this is 2 away from our line, and this is -2 away from their line, and they're mirrors of each other. That's going to be true always. And this is one way for us to check. So one way for us to really check whether we're doing it right. If these numbers come out and they're not opposites of each other, not negative and positive pairs, then we did something wrong. So let's see, our y is negative, our y is -4 and our x is -5. So I'm going to go ahead and find that point over here, and then one of our x-intercepts is -3, and the other one is -7. So that's a good way for us to check as well make sure that when we in this program, when we line up one in the right in one place, the other one should be in the right place too. And if it's not, then we need to go back and check our work. All right, that's it for graphing quadratics in factored form. If you have any questions, you're welcome to contact us online. Thank you very much. Mr. Bo English รับสอนนักเรียนตั้งแต่ป .3 ขึ้นไปทางอินเทอร์เน็ตในสไตล์ EP ครับ ผู้สนใจช่วยติดต่อครูแจงหรือไปเว็บไซต์ที่ www.mrboenglish.com